Have you ever wondered if you're not alone? And no, I don't mean the people around you. I mean another version of you, living a different life in a different universe. This isn't just science fiction. It's called the multiverse theory. Some scientists believe that our universe might be just one of countless parallel universes, and in each one, there is a you living a life that could be entirely different. You might be rich in one, poor in another, dead in one universe, and incredibly successful in another. The strangest part? Some theories suggest these universes might even overlap at times, and that strange feeling of déjà vu you sometimes get, it might be a fleeting glimpse into your other life. So, if you ever met your other self, what would you say? The theory of parallel universes suggests that the universe we live in is not the only one. There may be other universes, many of them, perhaps even an infinite number. Each one contains different versions of reality. Sometimes they are very similar, and sometimes unbelievably strange. How did this idea begin? It originated in quantum physics, specifically in an experiment called the double-slit experiment, which showed that particles can take more than one path at the same time. From there, the idea emerged that every possible outcome could occur in a separate universe. Scientists call this the many-worlds interpretation. That means every choice you make, every possibility, creates a new universe, where the other outcome actually happens. Imagine how many universes might exist just because you decided to be late today or said yes instead of no. And what's even more fascinating, some scientists believe that these universes might intersect at times, and those strange moments we feel, like déjà vu, could be subtle hints from another universe. But can we communicate with these universes? Can we see them? So far, no. Theoretically, it's possible, but we don't yet have the technology. Still, scientists continue to search, experiment, and question, because discovering parallel universes would change everything we know about existence. Just think about it. Maybe there's another version of you, watching this video right now, but living a completely different life. Some of the leading theories that support this idea, quantum mechanics, Hugh Everett's many worlds interpretation, suggests that every quantum possibility actually happens, but in a different universe. String theory proposes the existence of more dimensions than we perceive, opening the door to hidden universes. The Big Bang. Some scientists believe it wasn't the only one. There may have been other Big Bangs that created entirely separate universes. There is one question that, if we could answer it, might completely change the way we see reality. Can we prove the existence of parallel universes? For many years, this idea was treated as pure science fiction, but little by little, science began to ask the question seriously. Is there any way at all, to know if there's another universe beyond our own? The biggest problem lies in something deceptively simple. We are trapped inside our own universe. We can't step outside it to take a look from the outside, and we don't know if there's a window that leads to other universes. Yet despite that, scientists aren't giving up. If we can't see the parallel universes directly, maybe, just maybe, we can see their traces. Some researchers are trying to detect tiny, strange anomalies in the universe, like unexplained patterns in the cosmic microwave background or unusually cold regions in deep space. Could these be signs of a collision between our universe and another one? No one can confirm it. But at the same time, no one can rule it out either. Others go even further. What if there are particles that don't interact with light or matter, but somehow slip between universes? If such particles exist, and we succeed in detecting them, they could be the first indirect evidence that something exists beyond the boundaries of our universe. And while these ideas are still far from being proven, every experiment in a lab, every signal detected from space, could be a piece of the puzzle. Scientists today aren't searching for a magical doorway to another world. They're looking for a crack in the wall of reality, some tiny distortion, some unexplained glitch. That might be the key. But we must be honest, If it's even possible to prove parallel universes exist, it might not happen in 10 years, or even in 100. It might never happen at all. But one thing is certain: we now have the tools, the curiosity, and the courage to ask the question, is this universe really all there is? And every time we search for an answer, we get a little closer to that moment that could change everything. A moment when we open our eyes and realize that we've been living inside just one bubble within an ocean of universes we never knew existed. Lastly, what does the theory of parallel universes mean for us? Imagine for a moment that the life you're living isn't the only one, that there are other versions of you, thinking, loving, failing, succeeding, yet they are not you. Versions living in worlds you cannot see and may never know. Worlds that might be nearly identical to yours, or unimaginably different. In one of them, perhaps you took the other path. You stayed instead of leaving, said yes instead of no, followed a dream that faded here, but flourished there. What if that message you never sent changed someone's life in another universe? What if in another reality, you never lost the one you loved and continued the story that ended too soon here? Would that still be you? The theory of parallel universes, while scientific at its core, carries within it a deeply human and philosophical dimension. It doesn't just speak of a vast cosmos with no clear boundaries. It places you at the center of that mystery. If we exist in many versions, then who are we really? Is our consciousness bound to this body and this life, or is there an extension of us out there, living out decisions we never made? Imagine that every moment of hesitation, every choice you almost made, created a new path, a new world, a new life. This doesn't mean our lives are meaningless or that our choices don't matter, quite the opposite. If there are countless versions of you, then this version you are living right now is the only one you get to truly feel, see, and take responsibility for. Perhaps parallel universes do exist, but they won't come knocking. You won't open a door and suddenly see the life you didn't choose. But the very idea of their existence is enough to shake something deep inside, because suddenly we realize we're not defined only by what happened, but surrounded by endless possibilities that never did. And the moment you're living right now might be the final branch of a tree full of infinite choices. We don't know if this theory is true, but we know one thing. It changes the way we see everything: the past, the present, even the future. Because if you're surrounded by infinite versions of yourself, you truly only have one thing: this reality, this choice, this moment. So the real question is, will you let it slip away? Or will you live it, as if it's the only universe you'll ever have? In the end, whether parallel universes are real or not, the idea remains one of the most fascinating concepts that sparks our imagination and pushes us to ask, is this truly the only world? Or are there others waiting to be discovered? If you enjoyed the video, in a quiet night, you look up at the sky, stars scattered across the black canvas, galaxies swirling in silence. But what if that silence isn't real? What if space is full of whispers, whispers we just haven't learned to hear yet? In 1977, something strange happened. Astronomer Jerry Amon was monitoring the skies using a giant radio telescope known as the Big Ear in Ohio. Suddenly, a strong, unusual signal appeared, lasting for only 72 seconds. It wasn't noise, it wasn't interference, it was something else. Jerry was so stunned that he circled the signal and wrote one word next to it: "Wow." That's how it became known as the WOW signal, a one-time, unexplained burst that has never repeated, and whose source remains a mystery. And ever since, the big question has haunted scientists. Was someone trying to speak to us? But the WOW signal wasn't the only mystery. In recent decades, a new phenomenon has emerged, one that's even more puzzling. They're called fast radio bursts, or FRBs. These are ultra-short flashes of radio energy, lasting mere milliseconds, but carrying as much power as the sun produces in an entire day. The first was discovered in 2007, and since then, we've detected dozens. Some occur once and vanish forever. Others repeat again and again from the exact same spot in the sky, as if someone or something is trying to send a message. In 2020, astronomers detected a repeating signal coming from a galaxy over 500 million light-years away. It pulsed in regular cycles every 16 days. Same pattern, same strength, same rhythm. Imagine that. Something sending clockwork signals from 500 million light-years across the void. Scientists have suggested these bursts may be caused by neutron stars or exotic cosmic collisions. But the truth is, we don't really know. And the more we discover, the stranger it gets. So we return to the deeper question: are we alone in the universe? Our galaxy, the Milky Way, contains more than 100 billion stars. Almost all of them may have planets orbiting around them. And there are billions of other galaxies, each with their own billions of stars. The numbers are beyond comprehension. Could Earth really be the only place where intelligent life has evolved? That's the heart of the famous Fermi paradox. If intelligent life is statistically likely, then where is everyone? One possible answer? A chilling theory known as the dark forest hypothesis. Imagine the universe as a vast, dark forest. Every civilization is like a hunter, hiding, afraid to make a sound. Because any noise, any message could reveal your location and lead to your destruction. In that view, all advanced civilizations stay silent out of fear. And those signals we do hear might be rare moments of risk, or accidents, or final words. But humans didn't stay silent. In 1974, we sent the Arecibo message, a radio signal aimed at the stars, encoded with information about humanity, our DNA, our solar system, and simple images. We also launched the Voyager spacecraft, carrying golden records with music from Earth, greetings in 55 languages, and illustrations of human life. Messages to whoever might be out there. Will anyone ever find them? Maybe, but space is vast. Even light takes years, sometimes thousands of years, to travel between stars. Still, we listen. The SETI project, the search for extraterrestrial intelligence, uses the world's largest telescopes to scan the sky for signals. It focuses on patterns, regularities, and anything that doesn't look random. And recently, AI has joined the search, analyzing mountains of data for hidden signals we might have missed. In 2023, scientists announced 8 possible signals that may not be natural. We don't have proof yet, but the door is opening wider. Alongside science, conspiracies also grow. Some believe governments already made contact, but are hiding the truth. Leaks, rumors, documentaries all suggest a deeper story. Is it fantasy? Or is it a truth too big to reveal? For now, we don't know. But what we do know is this: the universe is not silent. It speaks, sometimes in whispers, sometimes in bursts. And we are just beginning to learn how to listen. Every signal we detect holds a possibility. Every stretch of silence holds a question. And with every step into the stars, we move closer to an answer. Is someone listening to us now? Is someone waiting for our reply? And do we have the courage to respond? Maybe one day, in this infinite cosmic ocean, what is time and space? Is it real, or is it just an illusion we've created to measure change? Since the dawn of human consciousness, we've been obsessed with time. We built sundials to track the sun's movement, created calendars to organize our days, and eventually invented atomic clocks that tick with unimaginable precision. But the more we understand time, the more mysterious it becomes, especially when we leave Earth. In space, time bends, it stretches, it warps, it flows differently depending on where you are, how fast you're moving, and what's around you. Time in space isn't the same as time on Earth. That's not science fiction, it's Einstein's reality. According to his theory of relativity, time is not a constant. It slows down near massive objects like black holes. It speeds up in low gravity. And if you could travel at the speed of light, time would stop completely. For you, imagine living a moment that never ends. Imagine returning to Earth to find that centuries have passed while you've aged just minutes. This isn't fantasy. It's been proven. Astronauts living aboard the International Space Station age slightly slower than people on Earth, by fractions of a second, yes, but real nonetheless. It's called time dilation, a direct consequence of motion and gravity, and it shatters everything we think we know about time. So what is time really? Is it a river flowing endlessly forward? Is it a loop repeating infinitely? Or is it just a human invention, a structure we impose on chaos so we can make sense of our lives? In the quantum realm, particles don't follow a single timeline. They exist in multiple states, in multiple places simultaneously. Time at that scale becomes fuzzy, ambiguous. The future can affect the past. Cause and effect blur. The rules break down, and yet we live by time. We worship it. We race against it. We fear it. We try to control it, organize it into hours, days, years. But time always wins. It's the quiet force behind everything we do. It ages our bodies, heals our wounds, carries us from birth to death. But in space, it behaves like a trickster, unpredictable, elusive, a reminder that the universe doesn't follow our rules. So is time real, or is it just how we perceive change? If a clock ticks in a black hole, does it still measure time? Or does it just mark the unraveling of everything we understand? Now imagine you're floating in the vacuum of space, no sunrises, no seasons, no ticking clocks, just silence. Would you still feel time passing, or would you lose all sense of it, becoming timeless yourself? Perhaps time is not something we observe, but something we are. A pulse embedded in our consciousness. A rhythm written into the code of existence itself. Our obsession with time may be less about science and more about fear. Fear of the unknown. Fear of our own impermanence. We measure time because we're afraid of running out of it. We try to understand time so we can defeat it, or at least outwit it. But what if the key isn't to master time, but to surrender to it, to flow with it, to accept its mystery, to stop fighting and start listening? Because in the end, time is not the enemy. It's the canvas, the backdrop on which all things unfold. Space gives us distance, time gives us meaning, and together they shape everything we are. So, the next time you look at the stars, remember this. You're not just seeing light, you're seeing the past. Some of those stars died long ago. Their light is only now reaching your eyes. Space is a map of memory, and time is the thread that weaves it together. Perhaps the real question isn't what is time in space, but what are we in time? Time is not a ticking clock. It's a living force, invisible yet undeniable. We don't move through time. Time moves through us. And in space, where gravity loosens its grip, we get a glimpse of what time truly is. Wild, fluid, unfixed. A dimension we barely understand. A truth that both humbles and expands us. We've sent spacecraft beyond the solar system. We've measured gravitational waves. We've stared into the abyss of black holes. But time still escapes us. It cannot be caught. It cannot be owned. It simply is. It pulses with the universe. It sings with the stars. And whether we understand it or not, it carries us, always forward. That's the mystery. That's the beauty. Time and space isn't just different. It's deeper, more profound. A reminder that our lives, brief as they are part of something vast, something timeless. So maybe the question isn't whether time is real in space. Maybe the question is, are you using your time, wherever you are, like it matters? Look up at the night sky and see a sea of stars, galaxies stretching across the darkness like scattered fireflies on a cosmic canvas. Telescopes reveal billions of galaxies, each filled with billions of stars, each star potentially harboring planets, and some of those planets, maybe even life. This is the visible universe, the part we can observe. But here's the unsettling truth. The visible universe is not the whole universe. It's just the part we can see, limited by the speed of light and the age of the cosmos. Beyond it, we don't know. It could be more galaxies, it could be nothing, it could be everything. What does it even mean to say beyond the universe? Is there an outside to something that includes all of space and time? The human mind struggles with this. We are creatures of borders, edges, and endings. Our lives are defined by beginnings and conclusions. But the universe, it doesn't care for such rules. It expands, not into something, but from itself. There is no outer space where the universe floats. It is space itself, stretching, growing, possibly infinitely. And yet we ask, what lies beyond the cosmic horizon? That imaginary boundary where the light hasn't had enough time to reach us. It's not that the universe ends there, it's that our ability to see does. It's like standing in the middle of a vast fog. You only see what the light allows, not because there's nothing more, but because your perception is bounded. Some theories suggest that the universe is infinite, no edge, no beyond, just an endless stretch of matter, energy, space, and time. But others say it's finite, curved like the surface of a sphere, where if you travel far enough in one direction, you end up where you started. But then again, what's outside that sphere? Is it a higher dimensional space, or is that question itself meaningless? Enter the idea of the multiverse, a concept both thrilling and terrifying. It suggests that our universe may be just one bubble in a vast cosmic foam, each bubble a universe with its own laws of physics, dimensions, and destinies. Some may collapse seconds after forming. Others may be so different from ours that matter as we know it doesn't exist. And somewhere, maybe one is almost exactly like ours, with a you who made a different choice, said a different word, became someone else. But if these other universes exist, can we ever reach them? See them? The answer for now is no. They lie beyond observational reality, beyond even theoretical grasp. They might exist forever behind a cosmic veil we cannot lift. And yet we wonder, because to be human is to question what lies just beyond the edge. The visible universe is like a message in a bottle floating in an infinite ocean. We see the message, we read its contents, we analyze the ink and paper, but we don't know how far the ocean stretches, or if it ever ends, or who else might be floating there. It humbles us, it frightens us, but it also drives us forward. The cosmic microwave background, the afterglow of the Big Bang, gives us a glimpse into the infant universe, but not before it. What came before time? Is before even a real concept when time itself was born in that fiery moment? Perhaps our questions break down at the limits of understanding. Perhaps the very idea of a before or outside the universe is like asking what's north of the North Pole. And yet, we build machines, launch telescopes, and write equations, all in pursuit of the unreachable, because deep inside us, there's a need to connect the dots, to feel part of something greater. When we look at the stars, we don't just see distant suns. We see ourselves, reflected in the infinite, searching for meaning. Philosophers have long debated whether the universe exists because we perceive it, or if we perceive it because it exists. Some suggest consciousness plays a role in shaping reality, that without an observer, reality is undefined, like a story unread. Could it be that the cosmos needs us, just as we need it? that awareness and existence are entangled in ways we can't yet understand. We measure the universe in light years, but we feel it in heartbeats. The distance to the nearest galaxy, the time it takes for light to reach us, it's all numbers. And yet there's something emotional about it, a quiet terror, a silent awe. We are so small, and the universe is so vast, and yet somehow we are here, asking the biggest questions. Maybe the question isn't what's outside the universe, but why are we inside it? What kind of reality allows for consciousness, curiosity, and wonder? If the universe had no edge, does our longing for one say more about the cosmos or about ourselves? And if we never find the answer, does that make the question any less important? The universe may never give us a reply. The stars don't whisper secrets. The galaxies don't write letters. But every time we look up, we feel something. A pull, a yearning, a sense that out there in the darkness, something waits. Not an answer, perhaps, but a deeper question. So we keep looking, not because we expect to find an edge or a wall or a sign that says, here it ends, but because the search itself gives us meaning. The act of wondering is what makes us human. And in that wondering, maybe we are touching the infinite, not with our hands, but with our minds. Imagine looking into the night sky where countless stars blaze like distant fires across an infinite canvas, and suddenly realizing that hidden among them exist regions where the universe itself bends and breaks the rules we take for granted. These are black holes, cosmic abysses where matter, energy, space, and time collapse into forms that defy comprehension, where light itself cannot escape, and where the familiar laws of physics are stretched to their limits. To contemplate a black hole is to confront the most extreme aspects of reality, a confrontation that is both terrifying and beautiful, a place where human imagination strains against the limits of understanding. From afar, they are invisible, yet their presence is undeniable. They shape galaxies, consume stars, bend light, and imprint themselves not through visibility, but through absence, through the distortion of everything that dares to approach. They are cosmic enigmas, shadows cast by the fundamental forces of nature, a reminder that the universe is stranger and more complex than our senses or instruments can fully grasp. If you imagine approaching one, the experience becomes almost unbearable to conceptualize. To a distant observer, time appears to slow as you near the event horizon, the point of no return. Your motions seem to freeze, stretched into an endless visual suspension. Yet for you, the traveler, the fall continues inexorably, silent and inevitable. Crossing the event horizon is not a dramatic act. It is a surrender to a gravity so extreme that space and time themselves are warped, where the familiar framework of cause and effect no longer functions. Beyond that boundary lies a singularity, a point of infinite density and curvature, where matter collapses, space and time merge, and the universe reveals its ultimate paradoxes. It is a place where before and after lose meaning, where the questions of existence, destruction, and creation converge, and where our understanding falters in awe. Inside a black hole, matter is crushed toward an infinitely dense singularity. Information paradoxes arise. What becomes of the stars, planets, and perhaps civilizations swallowed by these cosmic titans? Are they annihilated completely, erased from existence, or do they persist in a hidden, encoded form, embedded within the structure of space-time itself? This dilemma is one of the most profound in modern physics, bridging science and philosophy, and forcing us to confront the limits of knowledge. The very act of pondering these questions reminds us that our perception of reality is provisional, that there are domains of existence forever beyond observation, and that the search for understanding is as much an emotional and imaginative pursuit as it is an intellectual one. Yet black holes may not only destroy, they may also create. Some physicists proposed that singularities could act as seeds for new universes, birthing realities hidden within the folds of space-time. Imagine each black hole as a cosmic womb, a hidden beginning emerging from the collapse of matter. Perhaps our own universe originated from such a birth in a parent cosmos, a universe born from the singularity of a black hole in some unimaginable realm. This perspective transforms black holes from mere destroyers into participants in the eternal cycles of creation and transformation, linking endings with beginnings and highlighting the profound interconnections of matter, energy, space, and time across unimaginable scales. Beyond their physics, black holes serve as mirrors of the human mind, reflecting both our curiosity and our fear of the unknown. They confront us with absence, invisibility, and extremes of power that cannot be directly observed yet shape the cosmos profoundly. Supermassive black holes, millions or even billions of times the mass of our sun, anchor galaxies, regulate star formation, and orchestrate cosmic architecture. Their gravitational influence determines the fate of stars and planetary systems, showing us that true power often lies in unseen forces that operate quietly, subtly, yet with absolute consequence. They teach lessons about balance, influence, and the invisible forces that shape existence, both in the cosmos and metaphorically in our lives. Time near a black hole behaves in ways that defy intuition. Seconds stretch and dilate near the event horizon, while the traveler experiences a swift, inexorable descent. Time becomes a flexible, malleable dimension, reminding us that our ordinary experience of temporal flow is limited, relative, and contingent upon context. Black holes teach us that perception shapes reality, that the universe is relational, and that existence is more complex and subtle than our everyday understanding allows. They invite contemplation of time, memory, and causality, and challenge the certainty we place in linear progressions of past, present, and future. The aesthetics of black holes are equally profound. Accretion disks blaze with luminous intensity, jets of particles erupt across light years, and light itself bends into elegant halos under extreme gravity. This spectacle combines terror and beauty, creating a vision of sublime chaos, where immense power coexists with astonishing order. Black holes are laboratories not only of physics, but of contemplation, teaching that the extremes of the universe are intertwined with harmony, and that observation of these extremes invites reflection on the nature of existence, perception, and the sublime itself. Philosophically, black holes are humbling. Despite our most sophisticated instruments and the most advanced mathematics, we encounter the boundaries of comprehension. The singularity represents ultimate mystery, a limit where certainty ceases and the unknowable begins. In confronting these regions, we confront our own limitations and the provisional nature of understanding. The pursuit of knowledge becomes an act of wonder and humility, a recognition that the universe is far larger, stranger, and more intricate than our intellect can contain, and that curiosity must coexist with acceptance of uncertainty. Gravitational waves, ripples in space-time caused by merging black holes, provide unprecedented insight into cosmic events billions of years past. Each detection transmits a story of colossal energies, revealing processes that would otherwise remain invisible. These waves are bridges between theory and observation, past and present, chaos and structure. Through them, black holes communicate across time and space, offering glimpses into the hidden mechanics of reality and expanding our comprehension of gravity, energy, and cosmic evolution. Even when unseen, black holes dominate cosmic architecture. Their presence is felt in the motion of stars, the formation of galaxies, and the orchestration of cosmic dynamics. Their influence illustrates that significance need not be visible to exist, that power can operate silently yet completely, shaping reality in subtle and profound ways. This lesson resonates beyond astrophysics, suggesting that unseen forces, whether cosmic or human, can determine outcomes, structure complexity, and create enduring influence. At the singularity, matter is compressed to infinite density, space-time becomes indeterminate, and conventional notions of sequence, causality, and duration lose meaning. Yet from this extreme collapse may emerge creation. Within the paradoxes lie lessons about order within chaos, beginnings entwined with endings, and the deep interconnection between absence and presence. The universe, through black holes, teaches that mystery is intrinsic to reality, that extremes coexist with structure, and that the unknown is not to be feared, but explored. Black holes embody thresholds, confronting us with impermanence, uncertainty, and awe-inspiring power. They are laboratories for understanding the limits of physics, metaphors for human curiosity, and gateways to reflection on existence itself. They demand humility and imagination, encouraging contemplation of time, space, consciousness, and the very nature of reality. Through observation, simulation, and theory, we engage with these cosmic phenomena, not only scientifically, but emotionally and philosophically, exploring the universe while exploring ourselves. Their influence extends to the very structure of galaxies, where supermassive black holes govern the motion of billions of stars. Their gravitational pull organizes stellar populations, regulates star formation, and shapes cosmic evolution over billions of years. In this, they exemplify the delicate balance between chaos and order, destruction and creation, absence and presence. Their paradoxical nature reflects the dualities we encounter in life: endings and beginnings, destruction and growth, invisibility and profound influence. Black holes also illustrate the flexibility and relativity of time. Observers far from the event horizon perceive time differently than those near it, revealing that temporal experience is contingent, not absolute. This relativity challenges our understanding of life, memory, and causality, encouraging philosophical reflection on the nature of existence. Black holes teach that perception is inseparable from reality, and that the universe is far more complex than human intuition alone can grasp. The extraordinary visual phenomena associated with black holes, from accretion disks to relativistic jets, are spectacles of cosmic beauty and power. Light bends into ethereal arcs, matter spirals in violent yet mesmerizing patterns, and energy erupts with breathtaking intensity. These manifestations are reminders that the universe operates on scales both violent and sublime, that beauty can emerge from extremes, and that understanding requires both observation and imagination. Black holes challenge human arrogance. They reveal the limits of measurement, the boundaries of comprehension, and the necessity of humility. Even the most advanced theories encounter horizons they cannot cross, yet these challenges inspire inquiry, creativity, and wonder. By studying black holes, we learn that knowledge is provisional, that mystery is inherent, and that the pursuit of understanding is as valuable as its attainment. Through gravitational waves, light distortions, and cosmic interactions, black holes communicate the stories of the universe. Each signal, each observation, reveals patterns of matter and energy shaped by forces beyond ordinary perception. They offer insight into events that occurred billions of years ago, linking past with present, theory with reality, and chaos with structure. In listening to these cosmic echoes, we engage with a universe that is alive with complexity, mystery, and profound interconnectedness.